Good afternoon. I'm Kelly Houston with the California Emergency Management Agency. And this is pretty loud.
And I'm Deborah Hoffman with Cal EPA. And we're having a little technical problem right here, so we'll just try to fix that. We're coming to you live from Cal EMA Headquarters in the Sacramento area, and we're here to talk about tsunami preparedness, awareness, and tsunami debris.
And how ironic that here we are doing something technical and we have a technical glitch. So we're sorry we're a couple of minutes late, but luckily we're online live now. So for the next hour, we're just going to have a discussion. We're going to be talking about tsunamis. We're going to be talking about the tsunami debris issue, which there's been a lot of question about what are you talking about? What's this stuff in the ocean? Is it a problem? Should I not go to the coast? We're going to talk about what essentially you can do to become a part of the solution for that. And then we're going to show some resources that you'll be able to look at. And in fact, if you're watching on our webpage right now, if you look over on this side, you're going to see a list of links there. And it's to some videos, to some apps that we'll talk about a little bit later, and a whole lot of information about tsunamis. So even though we might not cover everything thoroughly in this live webcast, you'll have a lot of resources there to look at.
And I think one of the most important things about today is that you have the ability to kind of ask questions. We've got some experts here with us that can help us explain things. And so there's a couple of different ways you can log on and ask a question. You can get on the Twitter page. What's the hash?
Right. So you're online is at our Twitter site, which is at Cal EMA. Okay. So if you tweet and you use that, we'll be looking at that to see what your questions are. Underneath the video screen here, there's a questions or big red box. Click on that, and that's going to give you the opportunity to ask us a question live. And then you can also use the hashtag Cal EMA Live. That's CALEMA Live, and that is another way for us to follow the discussion. So even though you may not have a question, but you want to weigh in, you can comment on your stream using Twitter and that hashtag.
Yeah, and there are no stupid questions. Kelly and I are actually kind of learning as we go here. So we've been learning a lot about tsunamis over the past several weeks and months, and we're here to share some of that information with you folks. And I think now might be a good time
to
introduce
our
guest. This is Don Johnson. Don, say a little hello and tell folks what you do at Cal EPA.
Well, I work for California Environmental Protection Agency, and I'm the Assistant Secretary for Hazardous Materials Programs and also for Emergency Disaster Response Coordination.
All right. We also have Rick Wilson. Rick, why don't you tell everybody what you do and who you work for?
Yes, I'm with the California Geological Survey. I'm a senior engineering geologist there, and I guess you might consider me the state tsunami expert scientist for the state of California.
All right.
And then that's the big question. I'm like, wait a minute, geological, I think earthquakes and land.
Yeah, we'll get into that a little bit in my
What does that all mean, right?
I'll explain what the relationship is there.
Well, that's great.
And I think, in the past, we haven't really spent a lot of time in California talking about tsunamis because they seemed like something that, could never happen. But I think, over the past year, seeing what happened in Japan and realizing that we are at risk and it's something that we do need to prepare for, it must make your job a little more interesting.
Well, it has been a little busy lately, I'll say that. And, it's very unfortunate. It's one of those disasters that kills a lot of people in a very short matter of time. I think most people in these disasters within the first 45 minutes is the biggest time period where people can get killed. And that's unfortunate. It is an interesting topic from a geologic standpoint, but it's still very disastrous.
Right. Well, let's talk a little bit about tsunamis. I think when people hear the term tsunami, they think of this huge wave that comes and hits, but that's not really true.
Not always. Tsunami comes from the Japanese term for harbor wave. And it's not always a big wave. It can be a couple inches high, or it can be, 100 feet high. But in California, at different parts of our coast, which I'll talk a little bit about, it's different in different locations. And not every situation you're going to see a 100-foot wave or an inch high wave. So anything that's recordable is considered a tsunami when it's generated in that, in a way a tsunami is generated.
And then what perfect timing. It's just a coincidence that we're talking about tsunamis on Tsunami Preparedness Week. It's actually not a coincidence, but
that's the whole reason we're here.
Oh, is that right? Okay.
So yeah, why do we need to have a Tsunami Preparedness Week, and why is that something that's really important?
Well, I think, you know, as we look at, you know, 9/11 in our country, we look and see that that was a very terrible day in our history. The Japanese, they refer to this day, or that day that they had their tsunami, as 3/11. When I was in Japan as part of field teams, I noted that they had this on billboards all over the place, and that's how they think of it. It's that much of a disaster for them, and obviously they're still having to deal with a lot of issues with the nuclear reactor. So the same kinds of things can happen here, and that's the key, is that any state or community that's near the ocean has a potential of having tsunamis impact their community. And you know, so it's important for us to all realize that. The national programs have said we need to have a Tsunami Preparedness Week. The governor has proclaimed this as Tsunami Preparedness Week. We used to call it Tsunami Awareness and Preparedness Week, but people are more aware now, so we've just cut the title. And really, the preparedness is the key issue, and I hope that's really what we get to here, is how people can prepare.
And just, you know, a little bit later in the broadcast, we're going to talk a little bit more, Don, about some of the direct impacts that we still could be facing from the Japanese tsunami of last year, talking about some of the marine debris.
Yeah, I will be able to maybe answer questions that people have regarding what to expect and what we're doing to prepare for that.
And that has been one of the things that we've noticed, is that in the absence of information, and that was one of the big issues during the Japan earthquake and the tsunami, is that, and the government has been, you know, faulted in the early stages with not providing a lot of good information, and that, of course, creates a lot of misinformation. It opens the door for people to, you know, spread rumors and do those type of things. And so we've seen that there's been just sort of this void of understanding of what really happened. What's this debris, and is it, you know, there's a question about, is it radioactive because of Fukushima? Is it, you know, people's houses are going to be floating over intact? I mean, there's a lot of
visual images that went along with the tsunami and the destruction there that kind of are in people's minds, and that's what they think they're going to be seeing coming to California, and that's not the case.
All right. We'll get into a little bit more of that in a little bit. And one thing we should clarify also is that, you know, our government tried to do as much as they could to kind of get the information out. The Japanese government was faulted with not, you know, getting information out.
I guess I'm clear. Yeah, it's the local government in Japan. We had a lot of challenges here in California in trying to get information to people, and we also this one of the first times people actually heard real tsunami warning sirens on the coastline. The emergency alert system was activated, luckily on the north coast, and this week we've done a test up there amongst the local and federal agencies to test the system, which was yesterday. And so obviously it struck a lot of people by surprise, but we were lucky to have a lot of notice. We had that 9-hour window of time from when the first wave left Japan, so to speak, and came to California and actually hit our coastline.
And one thing that we're really fortunate to have here in California is we have that preparedness in place for many other different, you know, disasters and emergencies, and so we can kind of plug in.
We don't have to have a special response just for tsunamis or earthquakes, but we have a general response capabilities for all hazards and all kinds of disasters in California.
So let's learn a little bit about tsunamis, because
let's lay the foundation.
So we know. Rick brought a PowerPoint for us.
Yeah. Let's see if we can bring that up.
Our first test. Oh, good.
All right. My background is as a geologist. I work for California Geological Survey, but we have a tsunami program that's made up of primarily California Emergency Management Agency, who runs the program, and then our program as the science liaison for that whole all the work that's done under this program. And it's called the California Tsunami Hazard Mitigation and Preparation Program. And the key for me is that we need to identify the science part of it. We need to identify the risk and the hazard in order to really understand to how to mitigate the problem, how to prepare for the problem, so that when the next tsunami comes, people are prepared at the local community level. And that's really what we're talking about here, is the local communities. We have a national tsunami hazard mitigation program, which is made up of state partners, both scientists and emergency managers from every state and every territory in the U.S. And we also have membership from several federal agencies that are involved with this. The funding comes through the National Oceanographic and Atmospheric Administration. And really, it's a three-prong attack that we try to go forward against tsunami hazards. We have a hazards assessment group that looks specifically at what the risk is for different coastlines. We have a mitigation group which goes forward to develop plans to not only mitigate the hazards but also prepare for what might happen after a tsunami and what destruction there is to really kind of give us a little bit more resiliency in the state. And then we also have a warning group that looks at coordinating all different types of warnings that come out of our warning center, which is primarily the West Coast and Alaska Tsunami Warning Center. There's a lot of confusion because we also have a Pacific Warning Center, but for California, all that information comes out of the Alaska Warning Center. So when a tsunami warning comes, don't listen to the Pacific Warning Center. Go right to the Alaska Warning Center site if you want more information.
Why is that?
Well, they've separated the whole coastline based on, it's just the way they've separated it.
Okay.
The west coast of the U.S., Alaska, parts of the east coast are under the Alaska group, the warning center there, and the Pacific group does the Pacific Islands and most of the rest of the Pacific Rim, and then parts of the Caribbean. So they've kind of separated the tasks on which areas they really watch closely and who they send warnings to.
And isn't that mostly transparent to the general public? Like, you would get your warnings, you're going to get a warning, whether it's from one or the other, we're going to know about it, and it's not necessarily, you're not necessarily going to have to like Google through to figure out which is the right one to get it from,
No,
right?
but the key is that if we do get these warnings, that you pay attention to the one that's responsible for our area, because let's say the Pacific Warning Center puts Hawaii under a warning level, which means that it's possibly going to cause inundation of dry land and people need to evacuate low-lying areas. People may be reading that in California and they may go, I need to evacuate, and when it gets to California, it may not be the case. It may be much smaller, and that may not be a problem for us. So the Alaska group will tell us what we should be doing and what we should be expecting. But that's a good question. People really need to understand that difference. But listening to your local emergency managers is key because they have the most information, and Cal EMA also is the primary source for state information on this.
And that's going to be your the local warning point. So it would be your local weather alert. So if there's a tornado coming, you're going to hear the same alert for a tsunami warning through that same radio channel, the same thing. So it's not like I have to have a separate thing for tsunamis.
Exactly. Great. So my next slide, let's see if we can go to that. Oh, I should point out also that we have many partners in the state of California, not only federal and state agencies, but also a number of universities and actually private organizations, consulting firms that we work with, and they're listed there on the bottom. Won't go into great detail there, but we bring in a lot of expertise from a lot of different areas. So the main question a lot of people have is really what causes a tsunami, because I think we've seen a lot of pictures of tsunamis recently, especially from the Japanese event. But really what causes tsunamis? And the primary source for tsunamis are large submarine earthquakes, and they occur on what are called subduction zones, where one tectonic plate moves down underneath another tectonic plate. And it basically is a very large fault. Like we have the San Andreas on land, well, there's a very large fault offshore in many areas of the Pacific Rim. The bad news for our state is that we have one of these types of faults on our north coast, north of Cape Mendocino, called the Cascadia subduction zone. But south of Cape Mendocino, we don't have one of these faults, which is really important because that means we can't get the type of large tsunami that was generated in Japan locally. South of Cape Mendocino, we won't see a 30 to 100 foot wave. We could see 10 to 15 feet in many places, maybe up to 30 in some isolated areas, but we're lucky that we don't have a subduction zone along our entire coast. We still are very concerned about our north coast, though, and so that's why we evaluate these types of hazards on that particular fault. So if we can go to the video, the first video that shows how a subduction zone causes an earthquake and causes a tsunami, it's on that slide. So I guess I can show it. My hands or something. So the figure on the left is we call it a submarine fault there, but it's basically a large subduction zone. And if you can start the video for that.
They're trying.
Okay. Well, I can explain it. What happens is you see there the arrows pointing in different directions. Basically, along that fault, a lot of pressure builds up. Oh, that's the wrong one, but but that's okay. That's a landslide that causes a tsunami. And what you can see there is that when a landslide is triggered by a large earthquake, we can also get a tsunami from that. A wave is generated at the surface because the water column gets sucked down because of the tsunami. The landslide moves, and as the landslide moves away from that central location, it also pushes a wave away. So you have a negative and a positive wave, and that generates the tsunami, basically. Anytime you get a wave at the surface, gravity takes over, and that's when you get the tsunami generated.
And I may be jumping ahead here, but is that where people think, okay, it's this big wave that comes and hits, like you're going to see, it's going to be like a surfing competition where you expect to see that traditional wave, but they've talked about how the water recedes first. And is that as a result of that?
That's a good question. It happens, the receding water happens about 60% of the time. It doesn't happen in every case.
Oh, it doesn't.
So it's not always the best way to tell a tsunami is coming, but it is a good way if you have no other signs to tell you that you can use that. And I will talk a little bit about that.
Okay,
but,
great.
But that subduction zone, what happens, the same kind of thing. You have a very large rupture along that subduction zone. I can use my hands here. And when that seafloor uplifts because of that earthquake, it also creates a wave at the surface. And when that mound at the surface is created, gravity takes over and it creates a tsunami in both directions. If it's really close to a coast, you get a large tsunami. If it's a little bit further away, if you're going across the ocean, 10 hours later, like in the Japan event, it could be much smaller. So that's how tsunamis are generated. See if we can go to the next slide.
And just because we don't have these different plates off the coast in Southern California, for instance, doesn't mean they're not in jeopardy of ever having a tsunami event.
Right, and I'm glad you brought that up. I was a little discombobulated there with the videos. So the land, even though we don't have the large subduction zone, we do have very large faults in California, like the San Andreas Fault. We have large offshore faults, but most of these faults move this direction. They move laterally, not vertically. Okay. So they by themselves don't cause tsunamis. However, like you're kind of pointing out here, you can create a landslide offshore, which can cause a local tsunami to a number of places along our coast. Our whole coastline is possibly prone to this. It's a very rare event, but when it does happen, it can be devastating. There was an event back in 1989 where Papua New Guinea, a magnitude 7 earthquake offshore, triggered a landslide, which triggered a tsunami, and it killed 3,000 people locally. So we don't like to see that happen here, so that's why I'll go to the next slide here, where it talks about what you can do in a local tsunami. If you feel an earthquake, or you see the water receding, and you hear a loud roar of the ocean, those are your natural warning signs for a locally generated tsunami. So it's really important to pay attention to those. You're not going to have time to get a warning from the warning center, what we were just talking about. It's going to be immediately. So you're going to have about 10 to 15 minutes. If you're in a low-lying area that's prone to tsunamis, and we'll talk about how you can find out about that a little bit later, but if you are in one of these areas, you can go to high ground immediately to get away from the tsunami, because you may only have about 10 minutes to escape that. Now, we also have, obviously, during the March 11th event in 2011, we also had an official warning from a distant source tsunami. And you'll get warnings in this manner. There will be a number of warnings that, or messages that will come out, whether it's your TV, emergency personnel may go door to door, you may get a reverse 911 call, you may get it over the NOAA radio, weather radios, or hear sirens. The great thing about our society is that we have a lot of different ways of getting the message out. You may get a tweet, or get Facebook messages about it even. But the key is to follow what your local emergency personnel want you to do. They will have the best information about whether you should evacuate or not, if we do get either some kind of warning or advisory for our coast. Now, I should separate the difference between a warning. A warning level is anything over 3 feet, of a surge coming in. So over normal conditions, if it's 3 feet high or higher, that's called a warning level event, and that's where we may expect inundation of dry land. The advisory is below 3 feet. It's basically 3 to 1 feet. And generally, if you're on land, you're safe. It's just we don't want you to go down to the water and start looking at it. But we do see harbor damage in these types of events, the advisory level events, even if they aren't that big.
And that's kind of a natural human reaction sometimes. Oh, a tsunami's coming. I kind of want to go see what's happening. And that's the worst thing you could possibly do.
Yeah, it is the worst thing you can do. And actually, we had 1 death in California in the last tsunami because somebody did that. They went down, stood on some rocks with their friends and got knocked off the rocks and ended up drowning. So that's something we really don't want people to do. Right. We want them to go to high ground or just listen to their emergency personnel and tell them, you know, they'll tell you what you should do in that situation.
Okay.
And so here's the other question too, is that this is sort of the same thing that we talk about with earthquakes. So my mom lives in Modesto, which is in the Central Valley of California, and it's not necessarily on a fault. And so she's not concerned about earthquakes. She's like, why do I need a kit? Because I felt them. I felt the '89 earthquake, and there wasn't much, shaking. It was, pool water came out. And a lot of people miss the point of, well, you do, because if you visit the coast or you go, you're going to be that Murphy's Law person that is, over shopping at Christmas holidays along the coast or, whatever it is near the water.
Yeah.
Right. And that's why this is a great forum here to talk about it, because it isn't just people at the coast. It is visitors. It's people that may be coming from out of our state even, that maybe want to learn more about tsunamis in California, and they can go to this maybe in the future and see that, if they're on the coast, they have to be concerned, but not overly concerned.
All right.
Great.
So the next slide. So we had the last tsunami we had, the major tsunami we had, was the March 11th tsunami in 2011. And this is just a little bit of information about what happened here in California from that event. We had very large tidal fluctuations in Crescent City on the order of about 16 feet. Fortunately, though, we were at low tide conditions, so we didn't see significant inundation of dry land and any damage to anything on shore. Strong currents, we had very strong currents inside harbors and around bays. And the interesting thing and dangerous thing about this particular tsunami is it lasted a long time. Dangerous conditions within the water lasted for over 24 hours. And that's something people have to recognize, is that tsunamis are not the first wave, they're not the second or third wave, they can last for a very long period of time. And if people think that it's going to be over in 2 hours, it's not.
So a tsunami is not the wave itself as much as a series of waves or a series of, the way the water rises, really. Because sometimes it's not really even a wave as much as almost this kind of tidal surge.
That's a great point, and a lot of tsunami scientists don't like to use the word wave as much because they don't want that confusion.
Right.
It is a surge. It is like a flood, especially when they're very large and they're coming on dry land. It looks like a flooding river. And that's what makes them most dangerous, because they're very, very long wavelengths. The normal tidal surges are just a couple, they may be only 100 feet long, and they come in and break on the beach and then they disappear. For a tsunami, they could be hundreds of miles long. And because they're traveling at a very fast speed on offshore, up to 500 miles an hour, coming onshore, they slow down, and as they slow down, they kind of crumple up a little bit, but they also get bigger in size. And when they get bigger in size, that's where we start seeing the bigger waves. So, but they are large surges that come in and out and could last for up to 24 hours. I'd like to show you the one video from Santa Cruz at the top there. This was a situation, if we can start that video. This is a situation of a woman walking her dog.
And so set up the video. Is this a real video? It's like an actual...
This is a real video of the tsunami hitting the upper part of, there we go. And this is along the banks of Santa Cruz Harbor. And this was about 3 hours after first wave arrived. And this is one of the problems. We really don't like to see people down by the waterfront.
So this is somebody's home video.
Somebody's home video they're taking of the tsunami surge coming into the upper part of Santa Cruz Harbor. And again, this is 3 hours later after the first wave came in.
Oh, wow.
This tsunami bore, we call it, basically developed and just crumpled these docks and these boats, and was one of the reasons why they had a lot of damage there, is that these waves were caused. This is an area that doesn't normally see any wave activity because it's a good half-mile back into the harbor, and it's not built to withstand that kind of wave. And you can see many of the boats kind of floating up and down like they're in a bathtub.
And this was last year, right?
This was last year, the March 11th tsunami.
And so, was this the only thing that happened? In other words, was it just this one wave, or did they see a series of them?
No, there were 3 or 4 of these waves, but also strong currents developed up to about 15 to 20 miles an hour inside the harbor. And like I said, you don't normally see that inside a harbor. It's very calm conditions, and that's why boats dock there, it's because it's calm.
Had they evacuated that area?
Well, they had evacuated the docks and the boats for the most part.
Okay.
They did see, there were some people that did go down on the boats. Fortunately, we live with a lot of freedoms in our country, and unfortunately, there were people that took chances by going out and being on their boats or in other areas. We don't like to see that, and although we really appreciate the video that was taken here, I think it's going to be very useful when we evaluate things. It's one of those things that we don't like to see people that close to the water.
And this is the first time I've seen this. Actually, I'd never seen this, and this is incredible because it really kind of it shows you exactly what to expect. Because people were like, "Well, I didn't see any tidal wave come crashing over the top of a cliff, and it didn't rip homes off of the side of the." That's what you're thinking. You're thinking that kind of thing. Or is washing cars out. This is still as damaging.
Yes, this particular in this particular one harbor, there was $28 million worth of damage from the tsunami. 90% of the docks were damaged, and they're still going through recovery efforts there a year later, trying to rebuild parts of the harbor. So it can be economically devastating, and if anybody were on one of those boats, we could have lost more people. And you really got to give credit to the emergency managers who in the field trying to get that information out to the public, and it really worked in that case. Unfortunately, you do get some people that do want to get down by their boat, but you can't really help everything. So.
And it doesn't look like it's that huge of a wave, but you can see how destructive that movement of the water is.
It just took a little bit, and it did a lot of damage.
Right.
So I may be jumping ahead again, but here's the other thing that I learned out of this, and that was that the first wave is not necessarily the biggest wave, and in the Japan earthquake and that tsunami that hit our coast, the largest wave wasn't till many hours later.
Yeah, in California, actually, the largest waves occurred probably about 5 hours later, and then the highest surges happened 15 hours after when we had high tide and the strong tsunami condition. We actually had inundation of part of Crescent City 15 hours after first wave arrival.
So it's good for people to recognize that you shouldn't go back into an area that you've been evacuated from until someone tells you it's okay to go back. You don't just think for yourself, like, oh, it was a couple hours ago, I can go back in now.
That's exactly right, and that's the bottom line here, is that that's part of this education, is that people need to understand these are very long events, they're very dangerous events, and just because you haven't seen anything in the first couple hours doesn't mean it's not going to get worse.
So wait to hear the all clear from the folks that know.
Correct, yes.
Okay.
So go back to the video, or go back to the slide there, and that's okay. So in the tsunami, we also had about $50 million worth of damage. That was official damage that the federal disaster aid took care of. But ultimately, we ended up probably about $100 million worth of damage statewide from the event. We had damage to about 24 harbors statewide, and like I described before, we did have 1 death, and a number of people were injured on boats and near the waterfront area. So we really had a lot of lessons that we learned from this, and actually we've had several tsunamis in the last 3 years that have taught us some lessons. We really need to, I can't stress enough, keeping people away from the water is probably the primary task that's difficult to really maintain. Is a lot of coastal communities and communities in general have budget cuts, and they don't have as much personnel to be able to put out in the field, so they have to rely on temporary signage like this one at the top picture there you see from Monterey to really tell people that there's a problem and beaches need to be closed. We did have some concerns over some of the language barriers that and partially our fault at the state program for not putting in more effort to the Spanish-speaking communities and the Chinese-speaking communities and others who that need our help, because we did have some over-evacuation. People in the Spanish-speaking communities in Monterey and Santa Cruz ended up going all the way to the tops of the Santa Cruz Mountains to get away from the water. And that was unfortunate because it created a whole nother emergency situation up there. The evacuation successes we had, Crescent City evacuated, and it was very successful. They had gone through a test, evacuation drill just the year before. And then the last part there is talking, the slide, if I can get the slide back. Thank you. We really need to have more consistency along the coast overall. So, so that we have the same types of things going on with evacuations from community to community. And I'll go over this really quick, but the maritime community is obviously suffered a lot from this tsunami and several of the last tsunamis. We had successful evacuation of the commercial fishing fleet from Crescent City Harbor, and the key is we really need to help the harbors more with understanding if, when, and where they should move boats during a tsunami. And then just the recovery issues that can, I'm sure that Don can probably speak to with Cal EPA's interest in, some of the recovery of making sure that we don't see contamination within these harbors and other problems.
So there's a question, Steve emailed us a question asking us, how fast do the tsunami waves travel? Is this something, is it like a surf wave, I guess,
Yeah, tsunami, as I mentioned, in the open ocean, tsunamis travel about 500 miles an hour, like the speed of a jet plane, but they're very small. And as they come towards shore, bottom friction starts developing and they start to slow down. And usually when they're coming on shore, tsunamis can travel about 30 to 40 miles an hour. And then inside harbors, we've seen them up to 20 miles an hour in some locations. It was like about 15 miles per hour in Santa Cruz there with that one surge coming in. And although that doesn't seem like it's a lot, it really, if you have a big wave that's traveling that fast and there's no end in sight for the back part of the wave, like you said, it's a surge and it just keeps coming, that's very dangerous.
Go ahead.
Let's switch gears a little bit now and talk a little bit about California and what we're going to be seeing actually in the next year or so from the Japanese tsunami. And we should, stop for a second and recognize that it was a horrible tragedy for the people of Japan, and tens of thousands of deaths and entire towns destroyed, and literally washed out to sea.
It makes you sick. You've seen the video. Of course you have the videos of just people in the cars getting washed away, and it was tragic.
And so much of that was washed away. I'm sure a lot of it kind of sank and close to shore, but a lot of it is on its way over to the west coast of the United States.
Well, yes. When you look at those the videos and the photography from the tsunami, you see these whole cities being washed out and cars and everything. And so there's this image that all this debris is in an island floating towards California, and it really doesn't happen that way. A lot of that broke up, it sank. The Pacific Ocean has a lot of storms, especially the northern Pacific. And so there's a current, though, that runs from Japan through the North Pacific over towards Alaska and British Columbia, and then down the California coast and basically down to about the end of Baja California, and then heads back over towards Asia. So you have this big swirl that takes place with Hawaii and Midway Islands and stuff basically in the middle. And so debris from Japan will be in this northern current coming towards California, and it's spread out. So imagine now, I think the models show that the debris field is something like the size of California and Oregon combined. So it's spread out quite a bit. And most of what you saw that washed into the ocean would have sunk. It's heavier, it's not floating but plastics, household plastics, anything that's a sealed container that might survive, over time could float. But, large, the houses that we saw and all that other stuff, it's broken up and it's it sunk, and now it's spread out, and it's just become part of what's called a garbage patch.
So when could we start to expect to see? Well, we all saw the ghost ship that washed ashore in British Columbia last week. When can we start to see? Is that kind of the first sign that some of that debris is on its way? And what are our best guesses? Because we don't know for sure, right?
Well, yeah, we don't. And what we have is a computer model because we can no longer see the debris flow. It's not identifiable from satellite imaging, and even flyovers with planes, you really don't see any discernible debris. And when you think about it, it spreads out, it's small. Some of it might be floating right below the surface, so it's hard to track and follow. But the models show that between 2013 and into 2014, we could expect to start seeing increased amount of basically garbage and litter that comes into our coastal areas. But we don't know how much. And we all, it's mixed in with the debris that is coming from Asia anyway. I mean, there's that swirl that's going around, so it picks up everything from the Far East, comes in and around, and then it picks up our garbage that washes out to sea, and so it's mixed in with all of that.
So online, again, if you're watching and you want to ask a question, you can tweet us at Cal EMA, or you can use the hashtag, which is Cal EMA Live, which is, of course, we're live right now. You also have the opportunity to ask us a question through the link at the bottom of this screen. So if you look down there, it says Ask a Question. You can click on that, and that'll send us an email. Or if you're just in your email program and you want to send us a direct email, it's questions@calema.ca.gov. That's questions@calema.ca.gov.
And one of the questions that we've received is that debris going to be radioactive?
It's not expected to be radioactive, and when you
Why not?
When you look at the chain of events, the tidal wave, or the tsunami came in and washed all the debris out, and then the issues or the problems with the Fukushima power plant occurred after that. So it occurred right in the coastal area in more of a contained area, and wasn't part, that radioactive release was not part of the initial tsunami and the debris coming out. So there's one reason. The other one is that the isotopes that are released have one of them is a gas which has a very short half-life and dissipated within a few days. And then the other one, a cesium isotope, is water soluble, and it sort of just, if there is any contamination, it disperses in the water, and there wasn't enough release to really reach here in any noticeable amounts. The real risk might be is if there were, as part of the original tsunami, an industrial area that was impacted that might have industrial chemicals or isotopes that are in some sort of container that might float and survive the trip.
That's a long. What is that? How many thousands of miles?
Oh, man,
I think it's like,
I didn't measure it, but it's
I heard
3,500.
Yeah.
I think we back calculated 10 hours by 500 miles an hour, or what the speed it was traveling. I don't know what that is off the top of my head.
A long way.
It is a long
basically.
way, yes.
And so people, should they be concerned? Like, I know I shouldn't be because I'm here and I hear what all the experts say. I've talked to you. We've heard all that. But the general public is, if you were to tell them like you should be concerned or you shouldn't, how would you describe that?
Well, what we're expecting is that you'll probably see more trash on the beach. The floating plastic, things, household articles that float. There might be things like fishing gear and buoys that are lightweight and float. Now, the ship that is off the British Columbia now that's been tracked to have come from the tsunami, think about it. It's sitting above and bouncing on the top of the water, and the wind's hitting it, so it's both being driven by the current and winds. And so it's traveling a little faster than what you would expect most of the debris, which is either down in the water or just slightly above the water. But so what you're going to probably see is just mostly more trash that has to be picked up and cleaned up from our beaches. Now,
so we should be concerned about, the beauty of our beaches, and people should, go down to the beach and help out with these kind of beach cleanups. But as far as any actual danger from radiation or anything like that, that's not a concern. In fact, didn't they actually test?
They've done some limited testing, on another craft, a ship that was found, or a boat that was overturned, and some other debris. it's not comprehensive, but it gives you a first kind of a snapshot of what to expect that they don't expect it. Now, we are working with local agencies, our state agencies, and federal agencies, and every local jurisdiction along the coast has hazardous materials response teams that are available, and those teams, if something suspicious is found, and as the debris comes up, they'll be doing some monitoring, and part of that would be testing for radioactivity. But that's just a precaution. It's not really expected, and it's more to relieve fears from that the public might have as a result of that.
So I've got to ask a question here, because I got to ask this myself, and the answer may be obvious, but some people might think this: is there a way you can prevent a tsunami, or a way in which technology or something else could divert the impact of it? I mean, I don't know. You could I don't know what it would be, but
I think that's actually a really good point, Kelly. A good question. There are ways to at least prevent damage to buildings if you can build them stronger. If they're in an area that is a higher risk, you can change harbors, the setting within harbors. One of the things we're working on is a hazard map inside a harbor. So we have evacuation maps on land, but we're working on a hazard map inside the harbor to identify if you move boats around, during a tsunami, it may reduce the impact from that tsunami. So you can design things to withstand tsunamis, but sometimes it's too much. You can't do everything. But I think the most thing we're concerned about here is really the people. We want to make sure that they understand that even if you design a building to withstand a tsunami and you only have a minute or two to get up to a mountain, it's better that you go up there than wait inside that building.
Something, back to the tsunami debris issue, we have set up, can we tell people about the website, Kelly?
Sure.
disasterdebris.wordpress.com. And there's all kinds of great information on there about what you can do to help, what's being done right now, some frequently asked questions, the issue about the radiation and just what a very slight chance that anything could be radioactive in any way. If you have any questions like that, we have that website all set up, and also maybe some links to the California Coastal Commission, who are working on just kind of gearing up for some of these beach cleanups if we're going to see some more debris along the coast. And we all love our beaches in California. Go on out there and help out with one of those cleanups.
And that is the thing, is that, so you don't have to take our word for it. What we've done is brought everything together into, because people are like, well, I don't know, the government, I don't quite trust them, or, whatever that is. So we've brought everything together onto one portal, and that's this website, where you can look and see what NOAA is saying about it, what others are talking about it. These are folks that are either scientists, or the information is good information, so it validates us. And the bottom line out of this as well is that the sort of the takeaway is that it is going to get more attention to the coastal cleanups and keeping the coasts clean, and just knowing if there is something unusual when you're out there participating in one of those, how to deal with it.
And I know that we have been talking to not just folks in California, but in Washington and Oregon and British Columbia, Alaska, Hawaii. So that information is, kind of, put together from all different sources, from all these different scientists. So it's pretty good stuff.
I'm trying to figure out a trip to Hawaii. Don't you think we should take a trip to Hawaii? Go over there and monitor the coast?
We can do the same thing there, right?
Yeah.
That we're doing here?
Yeah, I can monitor from the beach. And I'll know, now that you've told me that, I'll know.
It's one of the first warning areas for debris. We'll know
Okay,
what
well then I
happens
need to be
when
on
we
the
see what
front
comes
line.
out.
Let's figure that out.
So you guys, if there's a take-home message that you want to share with the folks who are watching, what's the take-home message today? And I'm sure each of you have a different.
I think from the standpoint of preparedness, communities, the state, the federal government do a lot to help communities prepare, but it's really up to the individual. And I think if you really want to understand that your hazard, what level of what you have, whether you live, work, or play inside a tsunami hazard zone, you can go to a website. It's www.tsunami.ca.gov. Or you can go to the Cal EMA My Hazards website. You can Google that and find that website. Both websites are a great resource for identifying your hazard and have a lot of information about how to prepare for tsunamis.
And we have a lot of those links on the site
That's
that folks
great.
are watching on right now. So, Don?
Well, I think, again, to reassure folks that we don't expect a hazard from the debris itself, but we do expect it to be a nuisance and that it'll clutter the beach up, so there'll be some cleanup that'll be required. I would say that if somebody finds something that looks like it's of concern to them, so maybe something that looks like it came from an industrial setting and they want it checked out, that they should call their local environmental health or fire department. Both of them have hazardous materials response capability, and they can come out and they can check it out, and just to make sure that it is safe and it's not something that needs to be handled in a special manner.
But bottom line, you've been working with all these different agencies,
That's correct.
and kind of preparing for it, and
they're preparing for it and making sure that they have proper equipment to do the assessments and surveys out there.
So Safer Hermosa on Twitter is saying that they just wanted to let us know that Hermosa Beach is working on getting tsunami ready, I'm sure as a part of the this week's activities. And they have a run-up map online. So if you look at, if you search by Safer Hermosa on Twitter, you can get a link to their map and what they're doing locally there. And the other question, too, was, because we said this, what's the difference between a tsunami and a tidal wave?
Well, it's a tough one. A tidal wave implies that it's related to the tide itself. So when you think tidal wave, you think tidal changes. Tsunami is generated by a different mechanism, and kind of going back to the beginning that Deborah brought up with how is that related to geology? It's because of those earthquakes and those large faults and the landslides offshore that can create tsunamis. So it's a different mechanism that produces both. You know, a tidal wave can just be caused by tidal changes, but tsunamis are definitely caused by a change in the subsurface of the ocean or the surface of the ocean producing that wave.
It's great. This is great information. We're glad you guys joined us.
we're gonna have to do this.
having us.
We're gonna have to do this again, maybe. Yeah.
In Hawaii.
Yeah.
In Hawaii.
I like that idea.
That's where I want to go.
Well, thanks everybody for watching and for sending questions. And I'm sorry we didn't get to a lot of these questions because we're all talking too much. But but we'll do it again, right?
And we'll try to answer your questions as well. We'll see. We have questions in our queue, so we'll be answering those offline. And we also will be. We're always following you on Twitter at Cal EMA, and we'll be back again. So pay attention to our Twitter page. You can also friend us on Facebook. There's links on this actual website that you're watching us through to be able to link to our Facebook and Twitter accounts and other social media. And the more you join the discussion, the more information that's shared, and we'd like to hear from you and know exactly what we can do to help make things better for you and give you more information.
Yeah. What information is missing from that? You know, hey, you guys have all these links, and but you need to address this. So that's where you can come in and let us know how to help you.
Yeah.
All right.
All right. Well, thank you very much.
Thank you, gentlemen, for joining us. A lot of great information. Thanks.
Good.